Hello Year 9s. So we're now going to look at Chapter 6 in the GCSE textbook. We're going to revise formulae and functions from this. It's a big chapter. It's got a lot in it. Oh, by the way, there's my hand. It's got a lot in it. So we inevitably won't be able to get through all of it in this video, but I'm going to go through the basics of each, and then you can based on that, ask questions and do extra questions in your lesson on Thursday, your teams lesson. So the things we're going to look at, we're going to look at changing the subject of the formula, functions, expanding brackets, factorising quadratics, and then we're just going to talk about different forms of equivalences in algebra. Okay, so first thing, changing the subject of a formula. So this is where you're given a formula. Remember, formulae usually relate to sort of real life. They're usually sort of telling us something about real life. What you invariably start with is a formula that gives you something as the subject. So this one here has got A as the subject, is the thing on its own. And what you usually need to do is change the subject to be one of the other letters in the formula. So this is a relatively simple formula. So we're going to make P the subject. So first of all, you just need to have a little think about what sort of formula you've got. As I said, this is a relatively simple one. This has just got a P that has been multiplied by 2 and have 5 added to it. So you need to reverse that process, okay? Reversing that process means that you need to take away the 5. So you're doing it in the opposite order. So this has been multiplied by 2 and added 5. You're going to do the reverse. We're going to take away 5. And you treat it just like you would a normal equation. You do the same thing to both sides. So taking away 5 from this side, you've got to take it away from that side as well. And then to get P on its own, we're going to divide by 2. So we've made P the subject, okay? So the processes are the same as for algebra. So here I've taken away 5 from both sides and divided by 2 on both sides. As long as I do the same thing to both sides, I'm safe, okay? So that one was relatively simple because it was fairly easy to see what had happened to the P, and therefore fairly easy to reverse that out. These get a bit harder when the thing that you're trying to make the subject appears in more than one place in your formula. So here I've got mx plus n equals ox plus p, and I want to make x the subject. Now the problem is that x is in 2 places here. We've got an x here that has been multiplied by an m and had an n added to it, and we've got an x there that has been multiplied by O and has had P added to it. So step 1 has got to be x's on the same side. Okay, so getting the x's onto the same side, I'm going to subtract OX from both sides. I'm going to subtract OX. That's what I'm doing. So on this side, I'll have MX plus N minus OX. And I will no longer have OX on that side, so it equals P. Still trying to get X on the same side, I'm going to subtract N, okay, subtracting an N, and then I've just got my X's on one side and my letters that don't have any X's in them on the other side. If I want to make X the subject, it's got to appear just once in my formula, so I need to factorise this side of my formula in order to make X appear on its own. So that's an important step, factorising. So get all the X's on the same side. I'll write this as step 1, X is on one side, on the same side. Can't see it in green, can you? Step 2, got to factorise. And then the final step, I'm going to divide by my thing in brackets, which is the brackets m minus 0. So I take the whole of the m minus 0, I'm dividing through by that. That leaves x on its own there, and the m minus o on over there. Yeah, so that's a harder one because the x's are in two places. So that's the method for them. Get the x's on the same side, factorise, and then you can just divide through by the thing in brackets. I'm just going to do one more. So one more is just a little bit of a harder version of this. So here I've got the square root of x minus a over x plus b. Now this is going to take lots of steps to do, gents, so there's no shortcut here. So I've got x's in more than one place. Ultimately I want to get them next to each other on one side of my formula so that I can do that factorising thing. But I've got lots of steps to go through there. Yeah, these x's have had things added and subtracted to them. One is divided by the other and the whole thing is square rooted. First thing I'm going to do, I'm going to square both sides. That will get rid of that square root. Yeah, so I will be left with, I've got to square this side, that'll be 16. Yeah, so I've squared both sides. Next thing I want to do, I don't want this as a fraction, an algebraic fraction. I want to have all my x's in a line somehow so that I can get them all on one side in a line. So I am going to multiply by x plus b. And that's going to give me 16x plus b over on that side. Remember, when you multiply by something, when you move something, move it in a bracket, it's like moving it in a basket. Okay, so that gives me, if I multiply out that bracket, 16x plus 16b on that side. Now, I want to get all my x's onto the same side. So I'm going to subtract 16x, and I'll end up with x minus a minus 16x is 16b. If I add my a, I'll end up with all my non-x's on that side. So sorry, I'm adding a. All my non-x's are on that side, my x's are on this side. At last, I can factorise. You have got to be patient, chaps. You've got to get yourself to the point where you can do your factorising, yeah? So if x is common to both of these, I can put it outside the bracket. X brackets 1 minus 16 gives me that. Then I can divide by 1 minus 16. So we're left at x is 16b plus a all over 1 minus 16. X is now the subject of the formula because it's there all on its own, equal to something. That was a hard one. Lots of steps, gents, but hopefully those of you who are getting more familiar with these are getting the hang of them now. Okay, next thing I'm going to look at is functions. So functions. Functions are a way of telling us what is actually happening to usually an x value in a calculation, and we write them as f of x. Yeah, we usually write them of f of x as a f of x equals something. I'm just going to make one up here. X squared plus 5 over 2 we will use. Yeah, so why would we use this format instead of y equals x squared plus 5 over 2? Well, essentially it means exactly the same thing. It means that you are going to put a value in as for x, and when you square it, add 5 and divide by 2, you'll end up with your y value. Essentially it means exactly the same thing, just that this notation is nice because it describes the x in a bracket, and you can therefore choose your value of x. You could say something like f of 2. Yeah, that means put x equals 2 into your formula, into your equation. Yeah, okay. Other ways that you might see it written, you might see it written as a mapping. So you might have your x values here and your f of x values here. You might see that written. And also you might see it written with an arrow, f of x with an arrow. Yeah, they all mean the same thing. Okay, so f of 2, what does that mean? That means wherever there's an x in our formula, we're going to put a 2. So that's going to give us 2 squared plus 5 over 2. We do the squaring first. 2 squared is 4 plus 5 over 2. That's going to give me 9 over 2, which is 4.5, but I'm just happy to leave it as 9 over 2. Yeah. So if we were doing a mapping, we would say that 2 maps onto 9/2 in this function, this f of x function. Yeah, here we would say f of 2 maps onto 9/2. Yeah, that's what that sort of notation means. Okay, so that's what substituting in means. Be careful, gents. Some of you weren't very good when you had negative numbers in this in your homeworks that you've done. If you've got a negative number, just remember that that stays negative when you substitute it in. So it's going to be -2 all of that squared plus 5 for this function that we're looking at here, all over 2. So -2 squared is -2 times -2, that is 4, plus 5 over 2, we're back to our 9/2. And that is because a negative times a negative is a positive, yeah? So don't forget that, gents. Okay, so that's how you substitute into a function. Next thing we're going to have a quick look at, and it's going to draw on what I've literally just revised with you, and we're going to have a look at finding an inverse function, yeah? Finding an inverse function, and that is denoted by f to the -1 of x. That means the inverse function. Okay, so my suggestion for the way to do this, gents, is to take your function, set y equal to your function, and then change the subject of the formula. Yeah, so we're going to change the subject. Or actually, I'm not going to say change, I'm going to say make x the subject. Make x the subject. So if we're going to make x the subject, then we've got to undo what has happened to the x here. So here the x has been squared, it's had 5 added to it, and the whole thing's divided by 2. We're going to reverse that out, yeah? So the last thing I said was the whole thing was divided by 2. So we're going to start off by multiplying by 2. We do the reverse. So 2y equals x squared plus 5. So that x has been squared, it's had 5 added to it. The last thing I said was have 5 added to it, so we're going to do the opposite of that. We're going to take 5 away. 2y minus 5 equals x squared. We're changing the subject, we're making x the subject. The last thing we need to do in order to get x on its own is to square root both sides. So square root 2y minus 5, and you will get x. That was the final step of your workings to find your inverse function. What you now do is you write your f to the -1 of x, your inverse function, is equal to, and you must write this as your final stage, the square root of, now wherever there's a y in here, you just put an x, 2x minus 5. Okay, and that is your inverse function. So the process is set y equal to your function and then make x the subject. Do the changing the subject of the formula work that we've literally just done, and that will give you your inverse function. Okay, so that's how you do an inverse function calculation. Next thing we're going to have a quick look at is composite functions. Composite functions, we're going to need another function. So I'm going to use the function g of x is equal to 3x. So I've got two functions here. I've got f of x and g of x. Now I know that I can substitute into these. I know I can find inverses for them. So what I am going to look at now is the idea of a composite function, where I am going to do both functions to my x value. And what this means, perform g of x first, then substitute, just going to write substitute answer into f of x. Okay, so here are my two functions, f of x and g of x. I want to do f g of x. And I am going to start by putting in a number for x. I'm going to start with fg of 3, let's say. Okay, so my process is perform g of x first. So g of 3, g of x is a 3x function, so that means 3 times 3, which is 9. Then substitute my answer into f of x. So I want f of 9. Take my answer, I'm going to put it in as my x value into my f function. Here's my f function, there's my x. So I'm going to square the 9, x squared, so 9 squared plus 5 over 2. My working therefore will be 81, 9 hours of 81, plus 5 over 2, which is 86 over 2, which is 43. Yeah, so that's what a composite function is. You do the function closest to the value first, and then you do the second function. And if there was a third function, you would do that one next. And I think in previous examples I've given, I've done that. Okay, so fg of 3 gave me 43. I'm just going to demonstrate to you that it doesn't work the same way the other way round. So I'm going to go for gf of 3 this time. So my first step would be to do the f function because it's closest to that number. I'm going to do the f function first. So that's going to give me 3 squared plus 5 over 2. 3 squared is 9 plus 5 over 2. That's 14 over 2, which is 7. Then I take my 7 and I put it into the g function. G of 7 is going to be 3 times 7, which is 21, which is not the same as the answer we got last time, which I think was 43. Yeah. The other thing they could potentially ask you to do here is they could ask you to not substitute in a value for x, but give the composite function as a composite function in terms of x. So let's go back to fg of x here. So our first function, one that is closest to the x value is the g. So I'm going to say g of x is 3x. 3x is what has come out of my function when I've put x into it. So now my 3x is going to become my x value in my f function. So I'm now going to do f of 3x. That means I'm going to take 3x and I'm going to square all of it, because that's what I'm asked to do there, add 5 and divide by 2. If I'm squaring all of that, we'll go back to our indices chapter. We're going to have to square the 3, which gives me 9, and I'm going to have to square the x. That's 9x squared plus that 5 all over 2, and I think I'll just stop there. That could be 4.5x plus 2.5, but I think I'll just leave it in that form. Okay, so you might be asked to leave your function just as fg of x rather than substituting a number in. Okay, so that's functions for you. Last few bits now. I'm just going to do a little bit on expanding and factorising. So just a bit of expanding. Mainly we are going to be expanding double brackets here because we've done quite a lot of work on just a single bracket. So let's just do one, 3x minus 5x minus 2. So remember our process here. Our process is take the first term in the first bracket and multiply by the first term in the second bracket. I'm going to put an f there. So 3x times x is 3x squared. Then I'm going to take the outside term here, or the first term again, and multiply it with the outside term there. So those are the outside terms. Now I've got a 3x and I'm multiplying it by a minus 2. Be very careful with that negative number. 3 times minus 2 is minus 6, and it's an x. Then I look at these two inside numbers, inside. Again, be careful of the negative number here. I've got a -5 times an x, so -5x. And then finally, I've got the two last numbers. This is this FOIL acronym I'm sure you remember from before. -5 times -2 is +10. You must get those signs right, gentlemen. 3x squared then, simplifying this, -6x and -5x is -11x altogether, and +10 on the end. Okay, let's do another one. What about 2x minus 5 squared? Now I would call this a perfect square. If you get a question like this one, gents, what I want you to do is to write it out twice, because that will remind you that squaring something means multiplying the whole bracket by itself, yeah? And then apply this first 4x squared, outside -10x, inside -10x, last -5 times -5 is +25. So I've got 4x squared minus 20x plus 25. So this square thing, write it out, both brackets, yeah? Don't do anything else, no shortcuts. No shortcuts. If you take the shortcuts, gents, you'll get it wrong. Okay, and then finally, special one here, I'm going to do 2x minus 5 times 2x plus 5, okay? I'm going to apply the same process. So first, 4x squared, outsides plus 10x, insides minus 10x, lasts minus 25. Here I've got 4x squared. This 10x and minus 10x cancel each other out. I've just got a minus 25 on the end. Those x terms have disappeared. If you get a quadratic that doesn't have any x terms in it, and all of the other terms are square, as in square numbers, 4 is a square number, 25 is a square number, the x itself is squared, then this is called a difference of two squares. Difference of two squares, or dots, I call it, yeah? It's a square minus a square. This is 2x, all squared. So that's a square. This is 5 squared. That's a square. And the general rule for difference of two squares is that where you've got an a squared minus a b squared, so here this would be my a, and this would be my b, a squared minus b squared, the general rule is that it would be formed from an a plus b, a minus b pair of brackets. Here we've got the same value at the beginning of both, two x's, that's the a's, same value at the end of both, that's the b's, but the sign in the middle is different. I've got a plus and a minus, plus and a minus. That's called a difference of two squares. You need to look out for it. Okay, we're going to do a bit of factorising now. So factorising is putting the brackets back in to these quadratics, okay? X squared minus 4x plus 3 will do. What you have to do with these is you have to look for a pair of brackets that will work so that when you expand them back out, you get back to this quadratic, yeah? Clearly, if it starts with an x squared, the first term in both of them has got to be an x, so that when you multiply them together, you get x squared. Clearly, the last term here and the last term here, when you multiply them together, have got to give you plus 3. So that 3 has got to be a product of two numbers And those are the two numbers that go here. Now this particular one's nice and easy. There aren't many combinations of two numbers, factor pairs we call them, that are going to give you +3. In fact, there are only two. It can be 1 times 3 or -1 times -3. So those are the only numbers, 1 and 3 or -1 and -3, that would work to make us get a 3 at the end there. What we therefore have to look at to choose ours is that the sum of the two numbers that you have here must add up to -4. So the sum of your numbers has got to add up to this middle, we call it coefficient, number in front of the x. This only sum that will work here is the -1 and the -3, because we've got a negative number in the middle. Once you've done your factorising, before you sort of think, yeah, got it, just in your head multiply it out again. X squared, that works. -3x, I'm on my way. Minus another x, good, that gives me the -4x, and then +3. Okay, now these do get harder, and the place where they really get harder is when the number in front of the first x squared, that coefficient, we call it, is not a 1. Because that means that in our brackets, we are going to have a 2x and an x. Because that's the only way that we would get a 2x squared there. That means then that we've got to think about these products that we've got here. Still got to think about numbers that will give us -6 as a product, but we've got to think a little bit differently about the sum in the middle. Okay, so factor pairs that give us this product. So 1 and -6, -1 and 6. Oh, 2 and 3, or 2 and -3. And -3 and 2. Those are our options. Now, clearly, when we put those numbers into here, one of them is going to get multiplied by a 2. So we've got to look for numbers here that when we multiply by a 2 will give us the right number to then be added to the number that's here that is just multiplied by a 1. Now, for something like this, you could go through all of your factor pairs and just substitute them in and see whether they work. Yeah? And I'm sort of going to do that. I'm going to put a 1 here and a 6 here for a moment and have a little think about those, okay? Now, if I multiply a 2 by a 6, I'm going to get 12. That looks too big to me. The 1 won't work. If I multiply the 2 by a -6, again, too big. I'm going to get a -12. I can't do anything about that. I'm going to swap these numbers around. Then what about if I had the 6 here and the 1 there? I've got a 6x from here and a 2x from here. Actually, if I make that one the negative and that one the positive, it would work. And that's what I want you to think about, gents. I want you to think about your factor pairs. We didn't even get as far as looking at the 2's and 3's, or the 2's and -3's and -3's and 2's. Oh, that would have been that way around, wouldn't it? The process actually stopped once we got to here. This second pair of numbers worked. But you need to think about what's got to go here in the x values, and then think about your factor pairs for the product. Yeah? Okay, and then the last one that I just want to give us, I'm going to give us x squared minus 25. Hopefully it's screaming at you, gentlemen. Hopefully you are saying, oh, that's a square, that's a square. It's a difference of 2 squares. And if it's a difference of 2 squares, we know that we've got 2 brackets, both with the square root of the this term here, which is just an x, and both with the square root of that term in them here, which is 5. One of them's positive, one of them is negative. We do a harder one. Let's do 64x squared minus 81. This is square, This is square. It's also a difference of 2 squares. Square roots them. Square root of 64 is 8. So that's going to be an 8x and that's going to be an 8x. Square root of 81 is 9. 9 and 9, 2 different signs. If you multiply out those brackets, you'll get back to that. Okay, very last thing I want to mention. A bit of terminology. Some of the things I've used already. I'm just going to leave perhaps leave this here. Yeah. As this is a term. This is a term. And this is a term. Yeah. The whole thing, because we've linked the terms together with pluses and minuses, etc., the whole thing we call an expression. Okay. However, if I go a little step further and I set this equal to something, equal to y, because I've got an equals sign here, that makes that whole thing into an equation. Yeah? Okay, so I've got terms, individual terms. I've got the whole thing linked together is called an expression. As soon as I set it equal to something, I've turned it into an equation. Okay, the other word that I do use from time to time, numbers in front of x terms or y terms, I call them coefficients. So that's another useful one. Yeah. Okay, so that's an equation. If I was to change this into x squared minus 4x plus 3 equal to, and I think I had, what was this? This was, when I factorised it, was equal to x, what was it, minus 3x minus 1, wasn't it? Yeah, okay. If I set it equal to its factorised form, I am basically looking at something that is always going to be equal to this thing on the outside, on the other side, yeah? Because it's always equal to it, I am allowed to put an extra equal sign there. It almost means it's very equal to it. And that means that I've got an expression that is always equal to it, regardless of the value of x, always equal to it. And if I've got something that is always equal to something else, then the name for it in mathematics is an identity. So this means, I'm just going to write here, this is an identity. With an equation, if I set my y equal to 0, say, I could set it equal to 0, there are only 1 or 2 values of x, 2 in fact, that that this will work for. Yeah, won't be true for all values of x, but in an identity, this side is always equal to this side. Yeah, so an identity is always true. Just a couple of other bits of terminology that you have seen before. If I set my this quadratic that I've got here with this sign and a value on the other side, that's called an inequality. And I think you know that that means less than. That means less than or equal to. This would mean greater than. This is x squared minus 4x plus 3 is greater than. It's on the greater than side of the inequality than 0. And that would be greater than or equal to 0. So those are the main bits of terminology that we use in mathematics. So hopefully you can commit those to memory. And the rest of chapter 6, or any other sort of harder elements from chapter 6, I think you'll go through with some examples with your teacher in the lesson on Thursday on Teams.